Thank you. It's a pleasure. Yeah, thanks very much for the invitation to be here to talk about big data, as it is called by the industry. It is certainly a big buzz, and it's a big buzz for very good reasons. The opportunity, as you know, for impact through data analytics is absolutely huge. So, let's see. There we go. So to put it in context, as you know, with each evolution of the compute model, there is tremendous gains in efficiency. There's a step function with each one of these transitions. You have more users with access, the access is faster and it's easier, and the applications become richer, greater services, more usages. So you go all the way back to the 60s in the mainframe era. You had a very limited number of large corporations and governments that were using these machines for critical apps. Then you go to the 90s and the client-server model, and now you've got the emergence of productivity apps. Then 2000, obviously, the internet and the emergence of mobile apps, which was very exciting. And now 2010 and cloud computing. So you have cloud-based services, which by definition are on demand. You have the feeling of infinite capacity, and you have a very highly efficient use model. So this compute evolution has, at its foundations, I'm obviously from Intel, so I will say at its foundations is Moore's Law. And Moore's Law is an economic model that says with each generation, you're going to get greater and greater capacity at ever and ever lower cost. So one service that has now emerged through the build out of cloud computing is data analytics. And this is because you now have billions of connected devices streaming massive amounts of data, creating all new usages. So the reason for the interest in big data is the monetary opportunity available is immense. And there's always been value in information. So you can go all the way back to the carrier pigeons. They were the business intelligence solution of the 19th century. And Nathan Rothschild's extensive network of carrier pigeons across Europe gave him insights into the stock market that no one else had. So including he had very early knowledge that England had defeated France at Waterloo. And so as other traders were bracing for the British loss, Rothschilds went long. So you could say this was a very early form of insider trading. And the Rothschilds banking empire now has yielded the Rothschilds family assets in the region of $350 billion. So there's always been value in information. With the move to the digital service economy, data does become the new currency. It is the currency of the digital world. And so what has happened, as was mentioned earlier, is that everyone wants to capitalize on that opportunity. So IT orgs around the world have all started collecting data. And before my current role at Intel, I was actually Intel's CIO. And we jumped into the big data craze as well, and all these log files that used to be auto-deleted, we suddenly started to capture and hold. The unfortunate result, however, is that we're now all drowning in data. The number one cited barrier to adoption of big data analytics solutions is making sense of all the data. So we've acquired the data, and now we're waiting for these insights to come bubbling to the top. So there are four fundamental requirements of big data analytics solutions. So number one, you do want lots of data, and the more data, the better. You're going to get better insights the more data you have, so that's good. Number two is you've got to have the right algorithms and the right tools to analyze the data and generate insights. Three, you've got to have a lot of compute power, and four, you need expertise. So here's the problem. The historical IT world of business intelligence has developed IT experts that are steeped in the area of SQL. They're experts in the many reporting and BI and database administrative solutions. The problem is big data analytics environments are not a SQL world, and they require knowledge of all new languages like Java and MapReduce. They require even low-level understanding of Linux. So this knowledge crevasse in the big data glacier has got to be crossed. And so it's no wonder that the job of data scientist was declared by Harvard Business Review to be the sexiest job of the 21st century. And I know Harvard Business Review isn't a popular one here standing at Stanford, but they did declare it. So it is a field that is in hot demand, and so collectively we have to shore up this shortage. We have to shore up the expertise shortage, because being labeled by Harvard Business Review as a sexy isn't enough to actually close the supply-demand gap. Okay, so once we've solved the talent shortage, and once that's no longer the gate, there is still a very significant challenge in the process and the tools to actually analyze the data. The legacy BI world is one of very stable, very mature, enterprise-class solutions. They've been provided by a very large and healthy ecosystem of solutions providers. The workloads are different. They're very interactive, low latency, mostly structured data, and that process for building business intelligence solutions is very well established. Extract the data, prepare the data, model the data, report and take action. So you fast forward to the big data analytics world, and we're clearly missing that well-defined structure for solutions development. The workloads are currently designed for batch. They're improvingly moving to real time, but currently still batch. The latency is high. The data is clearly unstructured. And there is a very low maturity level in the tools, and certainly they do not have the enterprise class features that a business is going to want to deploy broadly. So this gap then creates a big opportunity for invention by all of us. And I had the opportunity to interview the #1 ranked data scientist on Kaggle. So Kaggle's the platform for analytics competitions that you may have looked into. The #1 ranked data scientist is Owen Zhang, and I was trying to understand, what does he attribute his success to? And he actually said he started as a sorcerer's apprentice, and that was what got him into the data analytics world. And I actually think he was being serious. So, if you think about it, though, the process, and as Owen describes it, the process is very complex. You have to explore this massive amount of data. You have to search for the right algorithm, and we're swimming in algorithms as well. You have to find an algorithm that actually fits the data and fits the case you're trying to make. Then you have to tune the model to make that prediction based on the data. Test it over and over again with as much data as you can obtain to gain confidence that the model is actually accurate. Deploy it out into production, and then continue to monitor and continually improve the accuracy of the model through machine learning. So it is an incredibly complex process. And we know that there is part of every one of these big data analytics solutions that is going to be unique to the customer and unique to the market segment. But there is also a very large part of the solution that is reusable. There's common reusable elements that we believe can be addressed through an open source platform. And so in my current group at Intel, we tackled this problem, and we developed and now have deployed an open source solution called TAP, so Trusted Analytics Platform. So it's a platform as a service. It's open and available for data scientists and application developers to build and deploy apps. It's hosted on Amazon Web Services, on Rackspace, on some hosters in Europe. TAP includes all the elements that are those fundamental building blocks, so the data platform components, Hadoop, Spark, et cetera, the data preparation, so transforming and filtering the data, the tools and algorithms for selecting the model and deploying the model, and then the interface, the data scientist developer interface and visualization tools. And then last, the analytics engines for actually detecting the anomalies, making the recommendations. So our hope is that the open source community comes together and contributes to the open source platform, and everyone benefits from a lower resistance, lowering the barriers to big data analytics solutions. So I do believe that data analytics is going to transform all industries, but it's a compelling place to start, and where we targeted our early proof of concepts for TAP, the Trusted Analytics Platform, was in addressing some big real-world challenges, like curing diseases and the world's food population. So we started a couple years back now, working with the Michael J. Fox Foundation, and it was at the insistence, actually, of one of Intel's co-founders, Andy Grove, who was the first CEO at Intel when I joined Intel 30 years ago. And Andy, unfortunately, is suffering from Parkinson's disease. So when he heard that I had moved out from being Intel's CIO to running the data center business and having responsibility for our big data analytics platform, he called me up and yelled at me and said, "Diane, go fix it." So I had the task of going and fixing the situation. And if you know Andy Grove, failure is no option. So we engaged with Andy's Research Institute as well as the Michael J. Fox Foundation. And what we did is we deployed wearable devices to those suffering from Parkinson's disease, and then using a big data analytics solution to improve the research and treatment for Parkinson's. So we're tracking now 300 events per second per patient, 24/7, on nearly 1,000 patients. So we track their steps, the tremors in their hands, their sleep patterns. And obviously, the more patient data we can collect, the more accurate the machine learning algorithms, the more accurate the models. So the data then is secured, and it's securely shared across research institutes around the world. So we unleash then all the brilliant researchers that have had theories on Parkinson's disease, on the treatments and on the disease progression, but they lacked the data and the insights to prove out those theories. Our second proof of concept was also in the health industry, and this is around curing cancer through precision medicine. So today, as you probably know, cancer patients are treated with a one-size-fits-all kind of standard care approach. So in reality, we all have very unique genetic makeup. Diseases have their own unique genetic profiles. And hence today, two people with the exact same advanced cancer will receive the exact same treatment, and one will live and one will die. And researchers don't know why. So in 2014, we announced an all-in-one-day initiative. And by that, we said we would collaborate with the industry to enable the sequencing of a full genome sequence, identify the genes, the fundamental genes that are causing the cancer, and then create the means to build a personalized treatment based on that cancerous tumor, and do that all in one day. So there's obviously enormous promise in the use of individuals' genomes to transform healthcare. And however, as we embarked on this path with the Oregon Science and Health University up in Oregon, there were some challenges. The first challenge, as you can imagine, is the data sets are enormous, absolutely enormous. So aggregating the data to do the analysis is prohibitive. The largest cancer center actually in the entire US has less than 1% of all genome sequences. So there needs to be some way to query all of the data sets available if you're going to get to a real result. The second big challenge is that the owners of the genome sequences see those sequences as their IP. It's their intellectual property. And hence, openly sharing those sequences is not something they're apt to do. So data security then becomes a real challenge as well. So that meant then we needed a distributed analytics solution with very high data security. So we partnered with OHSU, as I said, with their Cancer Research Institute, and we built a solution using TAP, using that open source analytics platform. And so I'm going to show you a cartoon version of how it works. So assume you have 3 cancer institutions around the US here, as you can see, that are willing to contribute their genome sequences into a data exchange. So a researcher then would subscribe to those genomic data exchange service, and he wants to look then across all the sequences for an image that matches the image of his patient's tumor. So he builds a query based on TAP. That query is then sent out to do the compare. So are there other tumors like this one? And if so, what was the treatment and what was the outcome? The results then are sent back to that central function. That central function, upon receipt, encrypts the image using hardware security features, and create a secure virtual machine, and then that virtual machine holds the results of the query. And when the data query across all sites and organizations is complete, the virtual machine is removed, eliminating all traces of the data, and enabling all 3 institutions to have securely shared their massive amounts of real-world patient data. So this solution will go live at the end of the first quarter of 2016. So we're making good progress with OHSU and 2 other institutions that are to be announced. So we're making good progress on our commitment to unleash technology on precision medicine and to create the right treatment all in one day. So this is starting with cancer, so we call this the Cancer Collaborative Cloud, but you can imagine it'll apply to every disease that is discoverable with DNA. So you can imagine an Alzheimer's cloud and a collaborative cardio cloud and so on and so forth. In the area of food production, we've been working with a small startup called FarmLogs, and they're a data science startup that's helping farmers maximize their crop productivity. So in the US alone, farmers must double their food production by 2050. At the same time, the amount of agricultural land in the US declines every single year. So they've got to figure out how to maximize their output using data. So what they do is they integrate data from satellite observations of the field over time. They combine that with crop yield data taken real time during the harvest, and they provide that yield map to the farmer to inform the harvest. In addition, they're using machine learning algorithms that they create a model of the field, and they refine that model over time, and then they're able to alert the farmer when there's a crop health issue emerging. So in doing so, the objective clearly is to increase productivity. So I have been called the accidental engineer, accidental because I enrolled in engineering at UC Davis without knowing what an engineer was. I was really tripped up when they said hardware or software. I didn't know there was more than one. So I did it for the money, I admit that. But I was told at the time by a guy in calculus that it was the highest paying salary with just a bachelor's degree, and at the time money seemed like a really good motivator. So I, though, have been in the industry, as I said, for 30 years now, all 30 years at Intel, and I've stayed because of the thrill of invention. And it is amazing what we have done and what we will continue to do through technology. And data analytics is the most recent example of a massive opportunity to be had. So I thank you, and I hope you will join us.